Hi, Algebra 2. Tonight's topic is on linear and quadratic regression, and we have 4 learning targets when it comes to regression. The first one is you want to be able to graph the data in the form of a scatter plot and determine if there's a pattern. The second learning target is you want to be able to identify what kind of pattern from the shape, and if it's a linear or quadratic. The third learning target is then you want to be able to find the equation for the curve of best fit using the graphing calculator. And last is you want to be able to make predictions using data, the scatter plot, or the equation of a curve of best fit. Okay, our first part here is just taking a look at a picture of a scatter plot. And if you just look at the picture in A and picture in B, and you think about the two functions that we're talking about, linear or quadratic, go ahead and pause the video and think about what A would be and then what B would be. Okay, hopefully you wrote down that A looks like a quadratic to you. It's a part of a parabola, so you should write quadratic. And B looks like a line, so B would be a linear function. Now the next thing is you want to use your knowledge of equation of a line and equation of a parabola to now come up with the equations. So for A, for our quadratic, the easiest one would be to use the vertex form. And our vertex looks about here with our quadratic, and it went to the right, and it looks about 1 unit to the right. So our H would be negative, would be positive 1 because it went to the right, but when we plug in, we'll end up being negative 1. And our K, it looks like it went up 2, so our K is 2. And it appears to be wider than normal, so I'm going to use approximately a 1/2 instead of a 1 because this parabola looks wider than our traditional parent function. So if I substitute all those values into our AH and K equation, we would have y equals 1/2 times x minus 1 squared plus 2. Okay, so that would be the equation for A. I want you to go ahead and try the equation for B using your knowledge of a line and look at the slope plus your y-intercept. So M would be slope and your y-intercept. Go ahead and pause the video and see if you can come up with the equation of this line. Okay, great. Hopefully you saw that the B is about 4 if you count up 4 units, and the slope looks like it's 2 over 1. So one possible equation that you could have estimated would be 2x plus 4, or something around approximately that. Alright, now we're going to look into problems that you're going to be using in regression, and we're going to be looking at the graph. And the first part is here, just make sure you're understanding that this looks like a quadratic and this looks like a linear, so anytime you see your scatter plot. So our first example here is about population and how it relates to the representative in Congress. And of course we know that there is a relationship here. Our founding fathers came up with this relationship to help balance our government. So the first part is we're going to be using our graphing calculator, so make sure you have that out. And we're going to be first write down the steps here to graph a scatter plot on the calculator. Okay, so our steps to graph a scatter plot, I first want to just have you write down the steps, and then I'll bring up the graphing calculator. Our first step is to hit the Stat button on your calculator, and then you're going to hit number 1 for Edit. Your second step is to clear your data from the L1 and L2 lists. Your third step is you're going to enter the independent variable, the X, into L1, and the dependent variable, the Y, into L2. Number 4 is you're going to turn on the stat plot by pushing second Y equals and enter, and then on and enter. Last step, number 5, is you're going to see the scatter plot, then you have to hit zoom number 9. Okay, so our data, if we think about what's represented here, we don't have all the 50 states. We only have 6 here, or 7. Let's see, 1, 2, 3, 4, 5, 6, 7 states. We have the population and the representatives. So as you remember from your government class, our population would be the independent. It matters what, how many people are in the state to determine how many representatives. So our X would be the population, that's the independent, and the representatives is dependent on the population, so that's our Y. So we're going to put the population data into L1 and the representative into L2. Okay. So we're going to make our scatter plot by, if you bring up your calculator, the first thing on that first step was to hit stat. Then you can see that you want to hit edit. Alright, I have some data in here. I want to clear that out first. It's easiest to go up to the L1 and then hit clear and hit enter. Then you want to go over to the L2 and hit clear and hit enter. Okay. Now you also want to make sure your diagnostics are on. So our diagnostics are turned on by going to the catalog. So if I turn on the catalog, let's make this a little bit smaller. To turn on the diagnostics, you want to go to the catalog, which is second 0. There's the catalog. And you want to go to diagnostics on. So you can quickly get there by hitting the D button and then going down to diagnostics on. Then hit enter twice. That will turn on your diagnostics and it'll allow you to see the regression analysis when you run your calculations. Okay. So now you're ready to put the data in. We know that our population is the X and our representative is the Y. So make sure you have your directions there and your notes ready to go. And we start with the button stat and edit. We've cleared the data already. So I'm going to put in L1 our population and type that in, 29.8, and then all the way down we got 18, 17, 12.9, enter, 6.6, 5.5, and then 4. Okay, that's your X data. Now you want to make sure your corresponding Y goes in the L2 accordingly. And so 52 is the representatives for California. Then 31 there for New York at 18 million. And 30 for Texas. 23 for Florida. 12. And 10 for 5.5, in Indiana, and then Alabama at 4 million has 7. All right. It's always a good habit to check again, verify your data, go through it, make sure you substitute in correctly every value. And then once you've verified it, now we're going to make sure our stat plot is on. So we're going to turn on the stat plot by hitting second y equals. This comes up, and that's why we hit enter. And then we want the stat plot to be on, so your cursor needs to be on and then hit enter. That turns the stat plot on. Now we want to see the stat plot, so we have to go to zoom stat, which is zoom number 9 for zoom stat. This will show us our scatter plot. Okay, those are a lot of steps. It gets easier the more you practice it. So we're just going to practice 2 problems today in the notes and then more in class. So here you can see our regression is a line, not a quadratic. So now that we have our graph, let's go back to fill in some of our notes. So here our relationship appears to be more linear than quadratic. It clearly looks like a line, not a parabola. Then we want to find the line of best fit and write the r-squared value. We do that by hitting stat, go over to calculate, and then number 4 for linear regression. Now it brings up your equation of your line. So you would substitute this in for A and this in for B, and we're also going to write down our r-squared value of 0.9996. You always want to use 4 decimals when you're talking about the correlation coefficient. That's what the r-squared stands for. Okay, so I just wrote out the calculator steps here, and then here's our line that our calculator gave us, and the r-squared value. Now it's a good habit to run the quadratic as well as you're determining. We are pretty positive it's linear, but let's just understand those steps. The same thing, but instead of hitting line, you're going to hit quadratic. So you hit stat, then over to calculate, and then 5 for the quadratic regression, and it comes up here. Notice that in A, our value is negative 1.55 times 10 to the negative 4. If you ever see the E in your value here, that's representing scientific notation. So I'm going to pause the video and write that down. Our r-squared, notice it's the same. So I'm going to write that down and then bring you back to talk about it. Okay. All right, question number 5 asks us to compare the r-squares and which one is higher. In this case, they're the same, so it's more important that we look at the graph. A lot of times the r-squared will be very different, so you'll go with the one higher, the one closest to 1. But in this case, they're the same, so the graph is what's going to help us determine it, and it clearly looks like a line. So for number 6, we're going to rewrite our regression equation. We've determined it's a line. So that equation was y equals 1.73x plus 0.39. And it makes sense. There is a direct relationship between the number of people in a state and the representatives in Congress. Okay, our last thing here is we're going to use our equation to predict the number of representatives for Oregon, which has a population of about 2.8 million. So to make a prediction, depending on what value they give you, you substitute into your equation. So they gave us the x value, so we're going to substitute in the x value of 2.8 and solve for y to find the representatives. When we do that, we substitute that in, we get a value of 5.23.